All right, so we're going to continue our box plots lesson here. You still need to know all the box plots, so if you've not done that activity yet, you need to make sure that you're doing those. We're going to continue that though, and what we're going to add on to it in this video is interquartile range and outliers. You really can't calculate your outliers unless you know your interquartile range. So let's take a look at that. Interquartile range is just the distance between the first and the third quartile. Now we have this data already lined up here for you. It's in order. We found the minimum, the maximum, Q1, Q2, and Q3. This is the median. This is the median of the lower half. This is the median of the upper half. The interquartile range is just the distance from Q1 to Q3. And the way that you can find the distance of something is just take the biggest of those numbers and subtract the smallest. Now it will always be Q3 minus Q1. You should probably write this down somewhere. Q3 minus Q1 is how you're going to find the interquartile range. Just like we would find regular range, we take max minus min. If we're talking about interquartile range, we want to take the biggest quartile minus the smallest quartile, which will be Q3 minus Q1 always. So in this case, Q3 is 17, Q1 is 10. We subtract those 17 minus 10 is 7. So our interquartile range for this data is 7. That's the length of this box here.
What percentage of the data is your interquartile range?
Yep, and remember, between the minimum and Q1 is 25, between Q1 and Q2 is 25%, between Q2 and Q3 is 25% of your data, and then between Q3 and max is 25% of your data. So the interquartile range right here would cover 50% of your data, because it's 25% here and 25% here, so that covers 50% of your data.
Okay.
That's the middle 50%. That's right. So, and then next is outliers. Well, what's an outlier? Well, it's a piece of data that lies outside of really where most of your data is. So an outlier, now let me read the definition, is a number that is so much bigger or smaller than the rest of the data that it can skew. In other words, kind of mess up your data and your results, okay? And to find that outlier, we are going to multiply that interquartile range, 7 in this case, by 1.5. 1.5 is kind of an arbitrary number. Just kind of go with it for now. We multiply it by 1.5, and I'm going to show you what we do with that length here on the next slide. But basically what we're saying is an outlier is a really, really, really small number that's really far away from your data, or a really big piece of data that's far from your data. So if you actually take a look at this, it starts at 5, 6, 7, 8. It doesn't look like this is very far from the data, but if you look up here at 35, 35 is pretty far from the rest of our data. It's pretty far out there, okay? And so what we kind of talk about when we're talking about outliers is like if you were to look at everybody's shoe size in the classroom, right? Everyone's shoe size. They would probably be around the same size because it's a class. We're 7th grade or 8th grade or 9th grade or whatever grades you're in. They'd have similar shoe sizes. But if Shaquille O'Neal walked in the door, sat down in a seat, he's going to have like a shoe size, what is it, 23? 23. That's huge. And so if we were to get all the data throughout all the chairs and everyone that's sitting in the room, you'd have a 23 size and everybody else would be like size 8. Right? There's an outlier in that group of data. A size 23 is huge, right? So in that case, that would be an outlier. In this case, we have an outlier, or at least what looks like an outlier is 35. It looks like it's really far and away from our rest of our group of data here. So let's take a look at on the next slide on how to calculate that. All right, so I have the same data set up here. Still got the interquartile range here of 7. And I even have put the box plot up here. What happened? Okay, thanks. So basically just plotted all those points, the minimum all the way to the maximum, made our box plot. You can check our past videos on how to do that. But you can see here, like our distance right here, not too far spread out. Our distance right here is not too far spread out. This distance right here is not too far spread out, but this distance right here is really spread out. And that tells me that there's possibly an outlier over here. Possibly. Okay, so I'm going to start showing you guys how to calculate that interquartile range. And just like we said on the last slide, we are going to take the interquartile range, in this case 7, and multiply it by 1.5. Well, what is, let me scroll down just a smidgen here, sorry. How do you find outliers? Okay, 1.5 times the interquartile range is 1.5 times 7, right? Because our interquartile range is 7. And that gives us, you got to turn that on.
We're going to
let Mr. Craig do the calculator.
7 times 1.5
should give us a good old 10.5 right there. Good, nice. So we have 10.5. So my interquartile range is 10.5. Oops, 10.5. And what I went ahead and did is I made a length that is about the length of 10.5 there. So it goes from 0, this is -1, so it's from 0 to 10.5. So this length is 10.5. And the way that we find outliers is we're going to go over here to quartile 3. Quartile 3 right here. And we are going to take that length and add it on. Anything past this point right here, this way, is going to be considered an outlier. Okay, so, well, what is quartile 3? We said that quartile 3 was 17. And so 17 plus this 10.5 right here would give us 27.5. So this right here should be about 27.5. So anything bigger than that 27.5 right there is going to be an outlier. Well, if you look up at our data, we actually have two numbers that are bigger than 27.5. We have 28 and 35. Because both of those points are bigger than my upper limit here, my 27.5, those 2 points are considered outliers. Those two numbers are so far away from the rest of my other data, we are going to consider them outliers. Okay, that's for like an upper limit though. That's on this side. How do we check the lower half or down here? How do we look for outliers down here? Now we've already talked about it. We don't think there are any. But I take that same length of 10.5. I'm going to go to quartile 1 right here and tack on my interquartile range times 1.5, which we said is a length of 10.5, right? And anything past this point right here, this way, would be an outlier. But is there any data past that point? There's not. If I were to take this distance here and go 10 and then minus the 10.5 to get down to this point, I'd get a -0.5. But there is no data past -0.5. The smallest point of data I have is 5, right? So I don't have any outliers on the left-hand side. I have outliers on the right-hand side. And what this means actually is that our data is kind of skewed. It's kind of messed up, and it's messed up on the right-hand side. It's skewed to the right. Okay, so that's where our outliers are. Let's go take a look at. You probably don't want to have to draw a box plot every time, so I'm going to show you guys how to calculate those by hand. Basically, to find the upper limit, we're going to go to Q3. Add this 10.5, which we found by multiplying 7 by 1.5. We're going to add that right there. That's going to be our upper limit. And then I'm going to take this interquartile range times 1.5, which is simplified, and go to Q1 and subtract it, because I have to go to the left, right? So, and that's how I'm going to find my lower limit, which we got here is -0.5. Let me show you how that works just algebraically, so you don't need a box plot in front of you. Okay, so for your lower limit, if you want to, write this down. You're going to do Q1 minus 1.5 times your IQR. In this case was 7. For your upper limit, you're going to do Q3 plus 1.5 times your IQR. In either case, though, I'm going to go full screen here so we can see all of this. For the lower limit, we went to Q1, which was at 10 right here. Probably move this off right now. And then we did our 1.5 times IQR, which was 1.5 times 7. That's what we did here, which was 10.5. And we ended up getting a -0.5. Okay? You can put that all in your calculator and find it that way. I showed you how to find that number right up here on the box plot, and that's how we got this number here. For our upper limit, kind of the same thing. We went to Q3, added this 10.5, right, which was the IQR times 1.5, and we got 27.5 for our upper limit, which we see right here. Okay, and then anything below this number is an outlier, and anything above this number is an outlier. And then we found two numbers in those areas, which was 28 and 35. So we have two outliers, 28 and 35. That's how you find outliers by hand. That's a lot of work. That's also something we do back in the 7th and 8th. All right, so what does that look like on a box plot? How do we represent these outliers on a box plot? Well, let me erase everything I've written up here to show you how we find outliers. The way that we represent these outliers up here at 28 and 35 is simply with some X's on the box plot. That's it. And you'll notice I put an X above 28 and I put an X above 35 to say, hey, these are outliers, but they're also still part of my data. Okay? Now, why doesn't this line go up to this point right here? Well, if 28 and 35 are outliers, what's the next point in my data? 18. So this right here is going to be at the point 18. That's as far as the whisker goes. There's no data between 18 and the next outlier, right? And there's no data between this outlier and that outlier. So we have two outliers. This is not a maximum. It's just the end of the whisker. This right here is still the maximum. at 35. That does not change our maximum. It just changes how we represent it because it's an outlier. Okay? This down here is still our minimum. Nothing else changed because we didn't have any outliers down here. But that's probably the most important part is the whisker goes up to the next point, and then you start listing out your outliers as you go. Okay? Let's see how we can do this on our calculator. All right, so this is the one we're going to do in our calculator. You notice it's out of order, and so a calculator is going to help us kind of get over this need to put it in order and all that. We're going to do the same thing where we go into second list to go into the stats menu and start typing everything in. We've shown you how to do this already. And we could go find the 5 boundary markers, but we're not going to this time. Let's go ahead and finish entering in this data real quick. All right, so this is how we normally how we can go find the 5 boundary markers. Let's do that really quick, where we go second list to go to the stats menu, go over to calc, do the 1 var stats, and then hit enter again, and you can get your 5 points by scrolling down. The minimum, the Q1, median, Q3, and maximum. Those are good to have if I need to make a box plot. But our calculator can also make a box plot for us. And the way that we do that is we need to go into this plot menu by doing second, y equals. And then it has 4 plots for us to go into. I'm just going to go into the first one by hitting enter. And right now it's set to off. And so I'm going to click enter to turn it on. And on the type, there are 8 different types, okay? And all these are different things. You don't need to worry about any of them except for the last one. The last one's where we want it. That is a box plot with outliers. The one before it does regular box plots without outliers. But the last option there does our outliers for us, which is nice. Okay? So we're going to make sure that's selected. Hit enter. So you can see it selected it. It's looking at the list 1, which is where I put my data in. And now we just need to go to graph, which is this button right here. But it doesn't look like it's showing me my whole box plot. So I need to go change the settings by going into zoom and then zoom stats, which is option 7. You can either scroll down to it or just click 7 down here. And now we can see our box plot. It does look like we have an outlier here. And our box plot, if you don't know how to get to each of these points, is just click on trace right here. And then you can go actually left and right to go find those points. And you'll see here, if you go all the way over to the left, it highlights this point. And you'll notice it says minimum x is 1. It says that the minimum 1 here, minimum x is 1 here as well. So that does work. But here's the thing. The next point is not the first quartile. It's the left-hand side of that whisker, right? It's where the whisker picks up. And if we keep on going right, now we're on the beginning of the box, which is quartile 1. It's at 10.5. If we hit right again, it's going to be on the median. The median is 12. Going to the right again, we see the third quartile is 15. It also tells me here that third quartile is 15. And then lastly, because there's no outliers over here, the end of the whisker is the maximum, and that's 17. So now it's really, really easy to make a box plot, find your outliers, find your quartile, find your interquartile range even. All this stuff's really easy to find. And then we can do it all on a calculator. If you don't have a TI-73, head on over to a search engine like Google, type in box plot calculator, okay? I'll also link one for you that I like a lot, and it'll do the same thing for you. You can find all those points, okay? That's it for this video. So good luck. Work on those problems down below and use those calculators. It's perfectly fine. We want to get into talking about what do these outliers do. In this case, the outliers on the left, and so this is kind of skewed more to the left. Okay, our data's screwed up, if you will, on the left-hand side. We've got an outlier here at 1, right? Because our minimum's 1, and that's where that outlier was. So that's skewed left. So work on those problems down below. Good luck.